If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You're listening to AFM radio on Astronomy.FM. Around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.FM.
The pirates are coming. The pirates are coming. The pirates are coming. You better watch out.
It's Space Pirate Radio time. Buckos here on Astronomy.FM radio. It is another Wednesday evening. I am your host, Captain Marty. My co-host, Captain Dianne, is unavailable tonight. So it's just you and me, listeners, for the next hour. And of course, it's going to be a live show. So come on over to the Astronomy.FM chat room and join me. I'm going to need your help tonight. If you got any questions on astronomy topics, you can type them into our chat room and I'll answer them for you right on the air. Oh, I should give us a little bit of the date and time and stuff like that. This is another Wednesday evening. It is January 17th, 2018, 9 o'clock in the evening for me here in the eastern portion of North America. Universal time, that would put it at 2 o'clock in the morning, Thursday morning, January the 18th, 2018. And as I said before, we have our chat room always open, but of course this is the time to come on in and join the Space Pirate crew by logging into the chat room and join me. I'm reading the chat room as the show goes along, so if you have any questions for me, I'll be happy to answer them for you. So far we've got, you can use a kind of a handle code name if you want to. Got Aqua for you. One of our Sky Guides is in there. Nick's here. Glenn, Twist Edge, Black Projects, Plaid Mac, Plaid Sister, Optronics, and Plaid Jones so far. An international audience listening in tonight. I've got, I had that flu a couple weeks ago that had kind of been going around the world and making everybody deadly sick. I had a mild version of it, but I got this lingering cough, which is like, it's like you ever get salt in the back of your throat and it just makes your throat kind of spaz and twist up and cough and can't get rid of it. Yeah, I still got something like that. So if you hear me stopping for a couple seconds, I'll try not to cough into your ear, of course. But I might just start coughing and then I'll mute it out for a little bit. So I'll do my best to keep us going along here. If you hear my voice kind of waver, yeah, that's a cough coming on. So feeling good though, but just got a little bit of that stuff in me. Maybe we should gargle some saltwater aquafuses. I think, no, this is Space Pirate. I need to gargle with some rum. I think that's going to do it for me tonight. All right, I got to start out with a little bit of, sorry, I'm not going to jump right into the big story, but I'll start out with the usual, semi-usual stuff whenever there is something on the sun to talk about. And yes, there is one sunspot. Right at the center of the sun is an active region designated 2696, and it shows up as a single sunspot. And it's pretty small, too. It's only about the size of the Earth's moon. Barely there, so kind of good test of optics. If you only get a chance to take your scope out with a solar filter and do a little observing during the daytime, you can kind of see if you can actually find the spot on the sun. Let me put a link to the sunspot into our chat room. And yeah, that's what we do here with our chat room. If I talk about something, if it's something on the internet, I'll put a link to it. And you can either look at that link or check it out a little bit later. We'll put these links into Space Pirate Radio Facebook page too. So come on over, like our Space Pirate Radio Facebook page, Space Pirate Radio, Astronomy.FM. And then a good place to find out if we got any special notices. For instance, if a show is not going to happen for holidays or technical reasons, that'll be in the Facebook page, so you can check it out. Now, some of you stay up pretty late at night to listen to the radio show. Appreciate that. And if it's a repeat, but one that you've heard before, don't necessarily want to stay up for that one. That's perfectly fine. So we got one sunspot, and that's about it. Far as solar activity, nothing really great. Not wind speeds, nothing much coming off of the sun right now. Wind speeds are low at 296 kilometers per second. Yeah, that's actually pretty slow for the sun. And particle density is pretty low, 2.94 protons per cubic centimeter. Yeah, that's one tiny particle of an atom for every cubic centimeter on average. And that's actually considered really low. So the sun, not too active right now. Once in a while, some of the magnetic fields on the sun will twist around and happen to spread apart and open up and something called a coronal hole. The corona is the outer portion of the sun, the very outer atmosphere. That's the big white thing you see in a solar eclipse photograph. Moon's generally covering the photosphere. Now, between the corona and the photosphere is called the chromosphere. That has a very reddish tinge to it. Bits and pieces of it can be seen during an eclipse. But otherwise, you mostly need a special telescope in order to see the chromosphere, called a hydrogen alpha telescope or hydrogen alpha filter for your telescope. That's when the sun looks, of course, super red, and that's where you can see solar flares. You can see stuff digging off the edge. Those are, sorry, a little cough here, prominences, twists and loops, and all different shapes. You see those with a hydrogen alpha telescope or filter. And the photosphere, you see that with basically what's called a white light filter. It dims down all the wavelengths of light, and that allows you to see the photosphere. The only way to see the corona, though, well, you have to either have a professional telescope, something called a coronagraph, that basically blocks out the whole photosphere and the chromosphere and allows you to see the corona, but amateurs don't have that. So the best way for an amateur to see the corona is by, of course, a solar eclipse. And the white light filters are what allow us to see sunspots on the sun. Nothing too special about them. They're generally associated with active regions, places where the magnetic field lines are kind of crunched up on the sun, and they'll appear generally a little bit brighter in H-alpha, and of course other wavelengths too, like ultraviolet and stuff like that. Let's see. Coronal holes are best seen in UV, correct? Yes, that is correct. I think X-rays also. Orbiting solar X-ray telescopes will also see coronal holes and ultraviolet light. That's what the SOHO mission actually looks mostly in, is ultraviolet light. In fact, if you go to the SOHO website, I usually just type in SOHO and then add the word sun, so you don't get neighborhoods of certain cities. And then where it says sun now, click on that, and it'll show different colors of the sun. It'll show like sometimes a blue one, a green one, a yellow one, and sometimes a reddish orange one. And up at the top, it'll say EIT 171, 185, 284, stuff like that. The EIT stands for extreme intensity, which basically means it's all ultraviolet light. I don't remember, that's a wavelength. The number that follows that is the wavelength, I think, in ultraviolet light. I believe that's correct. Look at the pictures and you'll see, well, especially like today, you can see that active region appearing as a bright spot. I like looking in the yellow image on this one. And just above that active region is a dark zone. And that is what's called a coronal hole. So there could be some particles coming out of that. I haven't read any reports if we're going to get hit with a little bit of extra stuff from the photosphere, particles streaming out of the sun, traveling through space, and if it's facing towards us just the right way, our magnetic field will actually grab it, pull it down towards the poles, and we'll be able to see it. Of course, this time of year, the northern hemisphere, the North Pole, is pretty much all 24 hours of darkness, so that's the best place for aurora to occur. Southern hemisphere, yeah, there's still a southern magnetic pole, and it's pulling stuff down too, but the South Pole has nothing but 24 hours of daylight, so no chance of seeing aurora in the southern hemisphere at, really close to the poles, Antarctica, stuff like that this time of year. Now, when we get into the opposite seasons, where it's winter down south and summer in the northern hemisphere, then the northern hemisphere loses those auroras, and the South Pole gains the auroras. So, kind of an interesting looking active region. Kind of butterfly, heart-shaped. Check it out. Let me pop it into this one into our chat room. And you can check out this yellow image if you're not going there by yourself and see what that looks like. Kind of an interesting looking active region. We're definitely heading towards slow time of the year for the sun, getting down to solar minimum. And there will be, obviously there's very few, and there might be more and more. There might be an extended period of no sunspots at all. Last solar minimum, I think it was a full 2 years of no sunspots. Not one sunspot for an entire 2 years on the sun. Something to look at. For Northern Hemisphere observers, I kind of keep forgetting to remind people, look at the sun, just the altitude of the sun, how high up it is at this time of year in January. And you'll notice that, look at it at noontime, and you'll notice that it is not very high. Yeah, this time of year, sun stays pretty close to the southern horizon, doesn't get very high up, and then heads back towards the west and sinks down below the horizon. So just kind of get a note, especially when it's one of those hazy days and you can kind of just barely see where the sun's at through the clouds or through the haze. You can kind of see its position and notice that at noontime it is really, really far south. In summertime, it's really high up. This time of year, it's really far down. Of course, just the opposite for the southern hemisphere. So always a little bit of something to look at on the sun. Now, when I look at the sun, when I can see it like through the clouds, through those thick clouds, and can see it as an actual round ball without any sunglasses or special filters, where it's just barely visible through the haze. I think of it as looking at this is kind of like sci-fi, Star Trek-y. This is the reactor core of the solar system, and you actually get to look at it when the clouds are thick enough to do that. Don't do it when it's really, really there's no clouds, but look at it when it's really thick and hazy, and just think, that is the actual reactor core of the solar system that you're looking at. That's what's pulling us around the entire Milky Way galaxy. That's our power supply. That's what keeps up life support on this planet. I have a little different way of looking at it, at the sun, instead of just a bright light that's a little bit too bright out there. Want to say hi to a couple more people that just joined us in chat. Balrong and Doug from Northern Cross Observatory. A couple of people from my local astronomy club, the Warren Astronomical Society. Welcome, guys. Glad to have you here. I'll keep checking the chat room as best I can. When I mention the chat room, that's a good time to pop your questions in. So if you can keep a question off to the side, and then when I say chat room, then pop it in, and then I can read it. If I'm just talking about some subject in astronomy, I'm probably gonna miss it. So. All right, got to talk about the meteor. If you haven't heard, depending on how far away you are from Michigan, you might have heard about it, might have not heard about it. Let me put in a link to the American Meteor Society. There was a big fireball last night here in Michigan. A little bit after 8 o'clock in the evening. Reports from about 9 after, 8 after, 10 after, stuff like that. Big fireball was seen. Couple different reports. Latest report, I have it as north of Detroit, about 20-ish miles or something like that. Very, very bright. Lots of a fair amount of videos caught at dash cams and stuff like that. People reporting seeing the sky light up, even if they didn't see it directly. Basically, the sky just kind of flashed up. And then what was reported from it was a boom and a rumble, kind of like thunder or a truck going over rough roads or something like that. And some people reporting that the resonance was one like lightning, when you get that fairly distant rumble coming across at you. You could actually kind of feel it in your chest. That's what's kind of reported. People say they were actually feeling the ground shaking a little bit. I had a feeling it was not the ground shaking. It was more like maybe the air just kind of at a low resonance, kind of rumbling across the way, and people kind of felt it as much as they heard it. I, of course, missed it. And a lot of other people I was catching on Facebook, yeah, they missed it too. I was inside. I got major roads by me. I always hear rumbles and stuff like that. I got a hospital near me. I hear sirens. And I think I was probably watching a movie on video, something like that. So I did not hear or see this one at all. But a lot of people did. Hundreds of reports went into the American Meteor Society on this one. Oh, yeah, there's been other ones like this, too, and there's been other ones like this that I've actually missed. So, kind of not that disappointed that I missed this one, too. Yeah, would be nice to see it, but no way. No, I was getting off work at that an hour before that, so if I had actually been on the road an hour later, if I stayed a little bit later, and I was driving, it took me about an hour and a half to get home from where I was working at this time, I probably would have seen it. But no such luck. So, wonder if there's going to be any particles, any meteorites. Now, in the sky, it's a meteor. When it's really bright, breaks up like that, it has a name called a bolide, especially if it has a little bit of sound to it. And if it actually has pieces of it on the ground, those would be called meteorites. Well, we'll see if anybody's able to actually collect any meteorites from this one, if it's possible. One thing that's good about this time of the year when it happens is that the lakes are still frozen. It's kind of, it's been cold enough, so everything should be frozen up. Now, the problem with lakes being frozen also is there's sometimes a lot of snow on the lakes. But if it's kind of been blown off and the lake's just basically ice and it's in an area called a debris field, which can be fairly wide, can be miles wide and miles long. And if it broke up and particles were actually able to make it down to the ground, the best place in Michigan would be a frozen lake, pond, something like that. Michigan is mostly woods, farmland. We don't have that much snow on the ground, about a foot or so. So a lot of it's melted away. So it's really hard finding a little pebble mixed in with, all the dirt and the rocks and snow and stuff mixed in trees and plants and stuff like that. It's almost impossible to see any type of rock basically laying around and knowing it was part of the meteorite. No, but the best place is out on a frozen lake. No guarantee if you find a rock on a frozen lake, because a lake still have houses around them, and houses can sometimes have kids, and kids will throw rocks out on the ice to see how far out they can get them too. So can't guarantee that the rock you find out on a lake actually came from that meteor, but there's a chance. But you really have to know about where it landed, and there's a lot of calculations for that, and maybe there's some stuff and maybe not. Well, a couple of suggestions here. Black rock, yep, if it was mostly stony. I think this one was probably mostly stone. I kind of looked at the video and the results that were coming in. My guess, we'll see how accurate it is when we get more people sighting in on this. My guess, this one was about 3 feet in diameter. About a third of the Chelyabinsk, so it had that big rumble, but it didn't blow out any windows or anything like that. So I'm going to just take a guess that it was about 3 feet in diameter, about 1 meter, and mostly rock. So it was not an iron one. That's my best guess, just by looking at the videos and the reports and stuff like that. So we'll see if somebody actually comes up with part of it or comes up with another analysis. And we'll see how close I am at my guess. So, yeah, Black Project saying, yeah, look for black stones. Definitely if it was rock, it would have a lot of material that was actually burning up. Well, kind of burning up. What happens is they used to think it was basically air friction sliding by the stone that would heat it up. But no, now it's thought that it's actual air compression. So that air in front of the rock, which is traveling anywhere between 30 to 60,000 miles an hour, compressing air causes it to heat up. That's basically way kind of part of the way an internal combustion engine works. Let me talk maybe more like an air compressor. Now an air compressor has those cooling fins because it gets hot. Well, it gets hot because squeezing one volume of air into a smaller space, all that heat gets crammed together, and it makes that air really, really hot. So the same thing happens for meteors, same thing. The air in front of the rock actually gets hot, really, really hot, and that's what heats up and melts the rock itself. Of course, it can't stand the stresses, so it'll just pop apart, and if it blows apart high enough up, each of those little pieces will have air compression in front of them, and they'll start burning up too. So a lot of the pieces will actually be fairly black. Try a magnet or metal detector. Yeah, that's a possibility too. Pretty much all meteorites have a little bit of iron in them, some more, some less. If it was mostly rocky, then most likely they won't have that much iron in them, but maybe a metal detector might be able to pick them up, so that'd be kind of interesting. If they really get the area of where most of the debris is thought to have come down, if there was any, and there's some snow on the ice, then it might be a good idea. Try a metal detector sweeping back and forth on the ice and see if you can pick up something that way. Maybe yes, maybe no. We'll see if anything actually turns up. And I know people are going to be hunting them. So. And be careful on the ice, too. Even though a small lake, something like that, can look pretty secure, test the ice and keep testing it as you're going along, because sometimes lakes have springs in them and the spring will well up and you might have several inches of ice and then you're down to a quarter of an inch and you fall through. So not a good thing. Be careful out on the lakes. Go looking for meteorites. And hopefully somebody will be able to come up with something. I'll have to talk to some people because I know people will be looking and see if I can get some for myself too. That'd be kind of cool. Wonder what they would call this one. Well, we'll see if they find out any stuff. All right, so remember my prediction about 3 feet in diameter, and we'll see if it comes true. So how about a little bit of what's going on in the sky lately? Kind of a slow week for astronomical events, actually. We only got 2 activities right now. The new moon. And Saturday, we've got Neptune 1.6 degrees north of the moon. And that's basically it for the moon and planets this week. Yeah, not much happening in the sky with the moon because it is new moon. So you got a good time for doing some deep sky observing. Me here in the northern hemisphere, it's more prime time for, a couple of the big galaxies are still up there, the Andromeda Galaxy and the Triangulum Galaxy, both part of the local group. And the Andromeda Galaxy, really easy to pick up in binoculars, reasonably easy to find. If you learn some constellations, finding the constellation of Pegasus, which right now is just beginning to set in the west and sticking up from the western horizon off one of the points of the Great Square of Pegasus is the constellation of Andromeda. And both galaxies are pretty close to Andromeda. The Andromeda Galaxy itself, pretty easy to see. Looks like a fuzzy cloud through a pair of binoculars, and you'll notice that it doesn't drift across the sky. It travels with the stars, so good way of telling that you're actually looking at a galaxy and not a real cloud. And then a little bit more towards the southeast is the Triangulum Galaxy. Again, both of them are actually part of the local group of galaxies, which includes the Milky Way, which you could see a little bit of the Milky Way if you get out in some dark skies. Now, this is more for Northern Hemisphere observers. We're actually looking at the outer regions of the band of the Milky Way. In the northern hemisphere summertime, when you look in the Scorpius Sagittarius region, you're looking towards the very center of the Milky Way galaxy. Right now, we're actually looking 180 degrees from the center of the galaxy. So we're looking at as you see the Milky Way band stretched overhead, you'll notice it gets kind of thinned out around the constellation of Cassiopeia and Pegasus. But the actual 180 degree part from in the sky, 180 degrees from the center of the Milky Way galaxy, is fairly close to a star in, technically it's in Taurus, but it looks like it's actually part of Auriga. Auriga is what looks like 5 stars that form a, I don't know, what do you call it? Not a pentagram, anyways, a 5-sided box. Okay. One of the stars, though, actually is Beta Taurus. It's called Elnarth. Elnarth is within just a couple of degrees from the 180 mark of the Milky Way galaxy. So if you're looking at the constellation of Cassiopeia and the star that the upper horn of Taurus, the bull, points towards, that's Elnarth, part of the 5-sided asterism of Auriga. Yeah, so right there, that star, almost 180 degrees of galactic coordinates. So you're basically looking straight out the edge of the Milky Way galaxy. And you might be surprised to know that Betelgeuse is almost right along the galactic equator. So that puts Orion pretty close to the band of the Milky Way, and it kind of travels between Sirius and Procyon in Betelgeuse, forming the Winter Triangle. So right through the middle of the Winter Triangle is the band of the Milky Way galaxy. And of course, if you've heard of it or not, there's kind of like a giant circle of stars all around Orion. So it's kind of fun to look at. Start out with this star in Taurus called Aldebaran. It's in the V-shaped cluster of the Hyades. And then going counterclockwise, it strangely enough goes in alphabetical order. So we're going to go to the west and north up to Capella. Then the 2 stars at the top. Capella's in Auriga. Then the 2 stars that make up the head of Gemini, Castor and Pollux, still in alphabetical order. Down towards the little dog, bright star there is Procyon. And then a little farther south to the big dog, Sirius, the brightest star in the sky. And then to the foot of Orion, the hunter, Rigel. All of them making a giant circle, a winter circle here for the northern hemisphere. Betelgeuse, somewhat in the middle-ish of the circle. Just a little asterism of stars to go find when you're outside showing people the nighttime sky. That's a kind of a good one to find. And try to learn the constellation of Orion too. When I first saw it, I didn't see it as a character of a person. I was seeing the 3 stars that make up the belt and the few stars that kind of below it. I thought it kind of looked like a Big Dipper, an upside down Big Dipper myself. The 3 stars of the belt of Orion were the bottom of the pan, and then Safe, the other foot of Orion, being the handle of the pan. So I was seeing it different than the traditional one when I first started learning the constellations, and I didn't know that was Orion. I just started looking around at the stars, and I thought, yeah, that looks like an upside down pan to me. Of course, the belt of Orion, and just south of that is a little cluster of stars that makes up the sword of Orion, and that is where you'll actually be able to see a gas cloud if you look very carefully with just your bare eyes. You have to have keen eyes. Darker sky is a little bit better, but you might notice that the little cluster of stars below the belt of Orion looks a little bit fuzzy, just barely. Yeah, that's actually a cloud of gas where the stars are actually forming brand new right now. In fact, go to the NASA website here. There's an article from NASA. Let me pull that one up. Something's been recently found. Let me put this article into our chat room. All right, let me pop it in here. But before we go to this, what Hubble actually found in the Orion Nebula, let's do a little station identification. You are listening to Space Pirate Radio here on Astronomy.FM. It is now 9:30 in the evening for me here in the eastern portion of North America on Wednesday, January the 17th, 2018. Universal time, that would put it Thursday morning, 2:30 in the morning, January the 18th, 2018. So we still have another half hour of live programming, and of course I welcome you to join everybody in the chat room. Great time to come on over. If you have any questions for me, you'd like me to answer on live on radio, I'd be more than happy to do that. This is a good time right now, right around the station break times. If you've got a question, go type it into the chat room. This is when I'm reading it, and I'll answer that question for you right on air. Chat room is always open, but during the live portion, that's when most people are here. Let's see, who we got in our chat room right now? We got me, of course, Aqua for You, Sky Guide Nick, Glenn, Twist Edge, Black Projects, Plaid Mac, Plaid Sister, Optronics, Plaid Joan, Balrong, Doug from Northern Cross Observer, and somebody actually just punched in anonymously. That works fine too, and you get a number, and this number is 854652. Welcome everybody to Space Pirate Radio and Astronomy.FM chat room. You can find the chat room right on our homepage of Astronomy.FM. Look where it says near the top, radio chat. Click on that button. Get you to the login page. Just type a name, handle, whatever you want. Make it pronounceable, make it nice, and hit the word login, and you'll be here in our chat room. So come on over. This is when things are happening. In fact, when you're in the chat room during this show, I consider you part of the Space Pirate Radio crew. A lot of people will put their images in here. We can take a look at stuff that other people have been doing, astronomy-wise. They've been going out to sea, pictures, things like that. So glad to have them. Glad to know what everybody else is doing out there. All right. Oh, one last thing on that big fireball. Somebody was asking, would it be possible to hit a jet airliner? Technically, it's possible, but when the meteors burn up, they usually start at about 60 miles high in the atmosphere. And then they start breaking up into a bunch of little pieces. Most of them burn up. And the lower you get down, the more they scatter. Now, 60 miles up is pretty high when you consider that an airliner flies at about 6 miles high. So from 60 miles to 6 miles, the stuff is pretty much broken up, scattered around, really thin. It's possible for some of the stuff to hit a plane. Damage. At that 6 miles, stuff's going pretty slow, actually. The jet would be going faster than the particles, so it's possible to get a window strike, small pebble, but the stuff is really spread out. So technically it's possible, but pretty much not possible for all practical purposes. Just the stuff's just too spread out if there's even enough of it to make it to the ground too. So yeah, as Doug was saying, not probable. Definitely not probable. Barely possible. Could hit a plane, do much damage? Probably not. But again, you never know. Stuff happens. I mean, all the billions of people in the world, I've heard of one for sure person getting hit by a meteorite. I don't know if there's been any others. A few people have made claims. A lot of fake claims about getting hit by meteorites, but one person I know for sure has been documented. 2 cars have been documented. Yeah, so not much. All right, where were we? What were we talking about? Oh, we're talking about Hubble and the Orion Nebula. Hubble has been finding a class of stars called brown dwarfs, or if you want to really call them substellar objects. They're not actually stars. What makes an object a star is, well, basically everything kind of starts out the same thing. A bunch of gas and dust collects together in a giant cloud, in this case the Orion Nebula, a very, very large cloud of gas and dust. And something takes over, a little bit of gravity, magnetic fields, starts pulling the stuff together. And the more particles you have stick together, the more gravity they have. And possibly magnetic fields are what some people are starting to say. We've got to cough here for a second. Okay, so depending on how fast the stuff pulls together, how much stuff is in the area, how fast it reacts will determine how big of an object is actually formed out of the gas cloud. Sometimes, and quite often, it will be stars. And sometimes really, really massive stars, just huge. Blue-white stars, some of the biggest new stars in the sky are formed in gas clouds, and that's usually what lights up the gas cloud. So if you're familiar with the Orion Nebula, especially there's 4 stars in the middle called the trapezium. Those are the ones that's actually lighting up the gas cloud. Those are big, fast burners, not going to last very long, but super, super bright. It's rather difficult to make really large stars. When the stuff comes together and the gas starts fusing together, and the star actually ignites, doesn't burn, it just starts bonding hydrogen, turning it into helium, creates a lot of energy. That's actually what makes the star push out and determines its size, how much stuff is there, how hot it is, push the star out. The right conditions, you get really big stars. But sometimes when that hydrogen fusion starts a little early, the starlight will actually blow away a lot of gas and dust in its vicinity, and it won't get really big. It kind of has to be just the right kind of blend of particles coming down towards the center at the right pace where you get enough stuff to come together and have it fuse at just the right time. So getting the maximum amount of stuff fusing together without blowing the rest of the gas away, pretty rare. So not very many of the really, really big, bright stars. The smaller the star, the easier it is to make. So the big, bright ones, very few. Medium size, like our sun, fair amount. Smaller ones, even easier to make. Smaller stars are called red dwarf stars. They're pretty small, fairly cool. Not much stuff in them. They're pretty small, and they'll last a long time because they fuse helium into hydrogen at a very, very slow rate. So they're economy stars. They stick around much, much longer even than our own sun. Now, the big stars might last tens of millions of years. Our own sun will last about 10 billion years. Red dwarfs, maybe something like around 100 billion years. Stuff's still sticking together, though. Not all of it has fusion in it, where the hydrogen combines to make helium, but the stuff will still gather together. Now, if the object collects enough stuff, and there's not much gas and dust in the area, it'll form something that's not quite a star. The hydrogen will still crash together, but there won't be enough of it to heat the object enough to fuse the hydrogen into helium, but there's still plenty of stuff there, so you will get a really big, semi-big ball of hydrogen gas that starts out hot just because gravity's squeezing it together, but that's all there is to it. And those are called brown dwarfs. Almost stars, but not quite stars. Now, in a cloud like the Orion Nebula, just forming, they're going to be fairly hot. But they're not going to stay hot for very long. They're basically just going to radiate their heat away and be kind of a giant planet, but in between of a giant planet and a star, the smallest stars, what's called the brown dwarf. So they're still emitting heat, especially when they're first formed, so they are detectable. They can be detected in the infrared, especially. I think some radio waves will pick them up too. So the smaller the object is, the easier it is to make them. So there has to be a lot of brown dwarfs inside the Orion Nebula, and the Hubble Space Telescope has found a bunch of them. In fact, they found some interesting things. Did I put that link into our chat room? Let me check in here, see if I did. I don't think so. Let me put that link into the chat room here for this article. Take a look at it. Here we go. And where did this come from? It came from NASA, the NASA homepage. Not only did they find brown dwarfs that were almost stars, but they also found the next size down object, which are really large planets. They found some brown dwarfs with planets orbiting around them. Giant planets. And they've also found giant planets orbiting giant planets. A binary planet system has been found. Again, the only way they know they're there is because they just form. They're squeezing together, so they do emit some heat. Not much, but enough for Hubble to actually detect it. Yeah, they found giant planets orbiting around giant planets. Isn't that interesting? So eventually they're going to cool down and just kind of wander through space. So just think that must be more giant planets, even singly, than there are red dwarfs. So try to imagine like giant Jupiters floating through the galaxy, and we don't see them if they've cooled down too much for us to detect. Yeah, there could be a sub brown dwarf star out there just floating around. In fact, the brown dwarfs themselves are definitely traveling through the Milky Way galaxy, and if it's been long enough, they would be cooled down, so we can't see them either. So, yeah, there's a lot of dark stuff out there wandering through the galaxies between the stars that we can't see because it's too cold for us. Check out that article. And again, yourself, you can go take a look at the Orion Nebula, especially if you got other people with you. Tell them all about the stuff that's in there. Brand new stars, all different sizes, bright enough to light up the gas cloud. Tons of little stars that aren't really stars, and then tons of giant planets are floating through that cloud of gas also. And of course, there's thought to be solar systems there too. Regular stars with planets around them are also inside the Orion Nebula too. It's an entire little system of stars and planets right there. Let's see where we want to go next. I had another article. Yes, another Hubble picture. Let me pop this one into the link into the chat room first. Again, we'll put these links into the Space Pirate Radio Facebook page, so you can check these out. If you're listening to the repeat, we do repeat this program every 4 hours for the next 24 hours. And if you happen to be listening on the repeat, you can go to the Space Pirate Radio page in Facebook and look at the links there. Then you could actually click on them while I'm talking about them, and you get to read the articles that way too. Also coming up, just give you a little reminder, we've also got the usual lineup of programs. We've got Astronomy Ireland, following Space Pirate Radio. We have Planetary Radio from the Planetary Society. We have Naked Astronomers, Naked Scientists, all coming up after Space Pirate Radio. With Space Pirate Radio, an entire 4-hour block of new programs to listen to. So check them out. Don't have to do it now. Again, got a whole 24 hours of listening to this stuff. Go ahead. All right. Hubble, looking at a cluster of galaxies. A giant cluster of galaxies. It has a nickname of El Gordo, translates in Spanish to the fat one. How far away is this thing? Well, let's see if it says how far away it is. I don't know if it says it. If anybody reads in the article, maybe you can figure out how far away it is. Well, anyways, it's thought to actually be two clusters of galaxies combining together with enough material of, now not necessarily all as stars, but stars, gas clouds, dark matter, thought enough stuff to weigh in about 3 million billion stars like our own sun. Say, not necessarily in the form of stars, but at least enough matter, enough mass that equals 3 million billion of our suns combining together all in this one cluster. Kind of cool galaxy cluster. In fact, if you look at this picture, which I just put up a link to, it's also on the NASA homepage. I think I counted about 5 or 6 stars. Well, individual stars. Again, clusters going, yeah, you're looking at millions of galaxies, and they would each have billions of stars in them. But stars that are in our Milky Way galaxy, I think I could see 5 of them. 1, 2, 3, 4, 5, 6, maybe. You can tell the stars because those are ones that have the diffraction spikes, little lines sticking out from the center. Those are actually stars within our Milky Way galaxy. Everything else in this picture is an individual galaxy, part of one of 2 clusters of galaxies that are all combining together to make a gigantic cluster of galaxies. This is also a way for astronomers to study dark matter by monitoring the motions of the galaxies and how much they would, for instance, bend light. The bigger galaxies would bend the light and allow them to see the galaxies behind them, and then kind of calculating how big the galaxy appears to how much the light is being bent, saying, oh, that's not enough stars to bend all that light. And that's where they get the idea of dark matter. And the dark matter is thought to be colliding in this galaxy cluster also. Well, that's pretty cool. A giant cluster of galaxies like that. Check that out. New Hubble image was posted yesterday, I think it was. I was going to mention on meteor showers. Yeah, there's not only, I don't know, I didn't know if anybody actually traced this Michigan meteor to a specific meteor shower, but there are lots of showers out there. Most of them are fairly small, not very many stars. I'm sorry, not very many meteors. Some of them will last fairly long time. Some of them, technically will last a month for a whole meteor shower, and some of them not very long at all. But I'll give you the list of meteor showers that are active right now. The aphelion, alpha hydrids, the January Chi Ursa Major, December Leonis minorids, Leo Minor, the Edicorvids, Lambda Boötids, the Gamma Ursa minorids. Let me put that link. Did I put it in our chat room yet? Let's see if it goes in there. Nope. Sorry. Wrong link. Let me redo this link. You can go to the American Meteor Society and check out the information too. They always put the current meteor showers right on their homepage. I always check it kind of regularly. So if you see a meteor, it is potentially part of a meteor shower. Now, I know there's like half a dozen really good, famous big meteor showers, but there's several dozen minor meteor showers. So when you're out at night, you see a meteor that during a peak, quote unquote, meteor shower time, and you see one coming from a different direction, it's either a random one or potentially, sorry, I got a cough again, potentially from another meteor shower that's actually going on also that not that many people know about. So there's a link for it. Again, Go to the American Meteor Society for that kind of stuff. Oh, did anybody actually see that launch of that? Was it SpaceX that was supposed to launch about a week ago, and then they had issues with it. It was a spy satellite supposed to go off. I can't remember what day. Fortunately, somebody sent me a link, and I was actually able to watch it and watch it and watch it. The countdown went up, went down, went up, went down, got down to, all right, no problem, we fixed it. 27 seconds to go, hold, and didn't go again. Guess they were having a problem with one of the arms attached to the rocket that's supposed to swing away, pull out all the links from the ground to the rocket just before it launches. They're having some sort of problem with it. My guess was it was a sensor that was bad. I think it was something to do with a locking pin for one of the swing arms. It was supposed to unlock, say it's unlocked, and get ready to swing out of the way. Well, I guess the swing arm sensor didn't say that it actually unlocked, so can't be really sure. You don't want to actually have a big metal framework attached to your rocket right when it's starting to go up. Not a good thing. So they're thinking that it was just a sensor error, trying some different parameters for changing what would be good and not good, but they tried and couldn't get it to go. I guess it went off several days, about a week later. A lot of people were watching this launch that didn't launch. Yeah, that's the way it goes in the rocket business. It's better to not launch than actually launch and hope it's going to be okay. A lot of people are mad. This is terrible. They don't know what they're doing. Like, well, yeah, they do know what they're doing. They're making sure that their cargo is really safe. So better to postpone launch and save your rocket. And it's not really for the public anyways, even though they were offering the public to watch this secret satellite launch. Another government one, which they admitted, yeah, it's a spy satellite. That means it's going to point down, set up. So it's interesting not seeing something launch too, but hoping that it would. I'm, kind of like people that like to watch certain activities, like, car races, because they just enjoy the car crashes. On a rocket launch, I'm not that way anymore. It's kind of fun watching the old videos of NASA and Russia when they were first getting into space and all their unmanned rockets that they were testing, that they'd go up, 20 feet, come crashing down, big explosion. Okay, that was kind of fun. That was cool. But now I'm more of like, no, let's have a good 100% success rate on a rocket launch. Sorry, my clock's chiming. It's a little fast, by the way. 10 minutes fast. All right, so it's good to have a good, full, successful rocket launch than have something explode, especially when you're, launching satellites in preparation for manned launches. You want every launch to be successful. So I'm not one for seeing a launch failure anymore. Watch the old videos on the old stuff. Okay, that was kind of cool watching them explode. Kind of funny sometimes, but to me, not anymore. We're way behind on big rocket launches anymore after the Saturn V. Now they're trying to get some of the big rockets built back together again and make them safe for sending people, traveling through the solar system and bigger satellites and stuff like that. So, no, I want them to all be successful, even if it's a mission I don't care about. Spy satellite, who cares? Oh, all right, here's something. Globular cluster with an invisible black hole. Let me put this one into our chat room. Let you think about, how could there be an invisible black hole? Well, yeah, that's kind of like a play on words, an invisible black hole. All black holes are invisible. But the way to detect a black hole is when a black hole happens to be really close to another star. And the other star's atmosphere gets pulled into the black hole, but before it gets pulled into the black hole, the material spirals around the black hole, and the closer it gets to the very last little bit before it gets pulled in, it gets really, really hot. So hot that it actually produces X-rays. So, if you're looking at part of the sky and you see X-rays from a star, there's a lot of X-rays. Well, there's no way that you're actually going to get a lot of X-rays coming from a normal star. So what it is the atmosphere of the star spiraling into a black hole, getting sped up, and emitting X-rays that way. So, yes, all black holes are invisible. You can detect a black hole if it's pulling material in, giving off X-rays. This one's not doing that. It's a black hole that does not have gas being pulled around it. But there still is a star orbiting it. And they can see the star moving in circles. And this one actually happens to be inside of a globular cluster. Globular cluster, I do believe this is a Milky Way globular cluster. A globular cluster is a ball of stars that actually orbits the center of the Milky Way galaxy. Doesn't orbit usually in the same plane as the rest of the stars in the Milky Way galaxy. So they will orbit like north to south and at different angles and go over the top and under the bottom and stuff like that. So basically circling the center, but not circling the center in the same plane as the rest of the stars. And our own Milky Way has about 150 globular clusters. Some other galaxies, especially giant ellipticals, you can actually see hundreds and hundreds of globular clusters around them, but not very many for our own Milky Way galaxy. Some of the more famous ones would be like M13, the cluster in Hercules. That's pretty popular. A bunch of them around the center of the galaxy, like M22. Globular cluster in Sagittarius. Lots of them all over the place. Just look on the Messier list and you'll see a whole bunch of them. This one doesn't have have a Messier designation. It has a New General Catalog designation of 3201. And they did notice that a star was moving around something that was invisible. I don't think it's really known that globular clusters have black holes. I don't believe they have black holes in the middle of them. Not like most galaxies have black holes in the middle of the galaxy, but I don't think most globulars have a black hole in the middle. This one is not a massive black hole. It's a little bit more stellar size, so it was really one single large star. Again, one of those big ones that don't really last very long. They form very early into in a gas cloud, and then live a very short time, just a few tens of millions of years at tops, and then the hydrogen runs out, and basically the core collapses. And if there's too much stuff in there, it collapses into a black hole. So nothing left but its gravity. This one happens to have a star next to it, but the star is far enough away where the atmosphere of the star is not actually being pulled into the black hole itself. They could see the star actually moving in a circle around nothing. And by noticing its speed and the diameter of that circle, they can tell that, it has to be orbiting a black hole, which I think has a mass of about 4 times our own Milky Way galaxy. It goes around at a reasonable pace. They can actually see this one I think is actually, they can see it maybe not moving in a circle, but moving towards us and away from us. So we're maybe looking at the system edge on. So you can look at the spectrum of the star and see how much the spectrum shifts one direction to the other direction. So it looks like the star is moving towards us and away from us, moving at several 100,000 kilometers per hour, and the pattern changes every 167 days. So it's definitely closer than the Earth is to the Sun, maybe something more like the distance between Venus and the Sun. that the star is actually circling around that black hole. Well, about time for me to head on out of here. Been an entire hour. I want to thank everybody that's been in our chat room tonight. Really appreciate you being here. Don't forget, we'll repeat this program every 4 hours for the next 24 hours. And coming up, Astronomy Island right after Space Pirate Radio. All right, thanks everybody for joining me tonight. See you all next week. Good night, all. Thanks. Arr.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
AFM.